Hey, welcome back. I'm just setting up my camera over here on the workbench to prepare for a shot that I want to show you of the project that I have going on down here. Let me get things adjusted. We're going to talk today about the shift register that we used in the 8-character 7-segment display that we built and set off to a JLC PCB to be manufactured. So I'm getting everything ready here. But before we start, here's a word from JLC PCB, who is sponsoring these videos. So in this video, we're going to talk about the 74HC599 shift register. Now, I've looked on YouTube and I see where there are several excellent videos talking about how this chip works and everything. So why am I doing another one? Well, there's two answers to that. One, we've been doing this series on designing your own printed circuit boards, and we use the chip in that series. So I want to show you how we use the 74HC595 to drive the segments on our display. But I also think that I would be able to show you some things that are not seen in those other videos. We're going to try to depict for you what's going on inside this chip, things that you wouldn't otherwise be able to see. And if you look at this board, you'll see where I have these 8 LEDs, just like you see in most of the other videos. But I've added a 9th one, this red LED. It's going to do something that maybe you haven't seen before. That'll be fun to talk about that. Let me walk you around the printed circuit board. Well, the first thing you're going to notice is that this breadboard looks a lot different than the rat's nest that I've shown you in earlier videos. But I wanted to set this one up so that it looked almost like a schematic. I want you to be able to easily see what's going on here with all the various connections. I've connected 2 breadboards together to give myself plenty of room, and then I've tied all of the 5-volt rails together here with these leads through here. I've got the ground rails connected through here, this little yellow jumper, and down there. So 5 volts and ground are distributed throughout all of the rails on the board. Our shift register is a serial to parallel converter. It allows us to take one data line and stream bits into the register and output 8 parallel streams all at once. It's really handy. In order to do that, you'll recall that we needed 3 lines coming from our Arduino. I'm simulating those lines with these 3 push buttons right here. Our clock over here, our latch in the middle, and our data pin. The latch is quite simple. Basically, we have a push button. When we press this button down here, we're sending 5 volts to the latch pin on our IC. That was simple. The data pin works the same way. When the button is up, this line is grounded, and that's a low going into the data pin. If I push the button down, the line goes high, and we have a 1 then at our data pin. I ran into some issues with this one. I noticed that I was getting high readings when the button wasn't pressed. This is because when the button's not pressed, it's actually floating, and that floating voltage might occasionally trigger a high down here that's unintentional. So what I did was I added a 1000 ohm resistor right here. We call this a pull-down resistor that will hold this line at 0 volts until that button is pushed. So that solved the problem there. The clock pin is something else altogether. According to the Texas Instrument datasheet on this chip, the clock frequency can be as high as 20 megahertz. That means that the clock pulse can be as short as 20 nanoseconds. 20 nanoseconds? Well, think about this. A millisecond is 1,000th of a second. A microsecond is 1,000th of a millisecond. And a nanosecond is 1,000th of a microsecond. That means that when I push this button on the board, there's absolutely no way that I can keep the clock from reading dozens and dozens of pulses. It'll think that I'm sending lots and lots of data to it. We call this switch bounce. So in order to solve the problem, I've had to connect my switch to an Arduino. So instead of going straight to the clock pin on our IC, I'm running this pin over to the Arduino, and I'm having the Arduino send a nice clean pulse back to our shift register. That's how we solved that problem. Now let's look at all 16 connections on our shift register. Pin 1 right here is the second connection on our parallel output. It's the 1 bit. It goes over here and connects to this current limiting resistor and then goes to this second LED. Pins 2, 3, 4, 5, 6, and 7 all do the same thing. One line for each of the bits. Pin 8 over here is tied to the ground rail. Now let's look at the pins on the other side of the chip. Over here we have pin 9. Pin 9 is the serial data output. This is the one that we use to daisy chain to other chips so that we could put multiple shift registers cascading together. I'm bringing this line right now over to another current limiting resistor, and although it's out of connection right now, I have a red LED that we'll place in here later so that you can see what's going on with that pin. Pin 10 is our register clear pin. Normally we have this connected straight to 5 volts. I've included a jumper wire here so that we can show you some interesting things. If you would like to add in a 4th line from your Arduino, you can make use of this pin. Pin 11 is the clock pin. It's going to get its pulse from our Arduino. Pin 12 over here is the latch pin, and it goes, of course, over to our button there. Pin 13 is our output enabled pin, and we have that set at ground. Pin 14 is our data pin. It goes over to this switch. Pin 15 over here is the 0 bit. It wraps around here, goes to this first lead, to this current limiting resistor, and we use it to light our first LED. And then finally, pin 16 over here is our VCC, and it's connected to 5 volts. Okay, now bear with me, people. The only thing worse than doing a live demo is doing a live demo with marbles. At least this isn't a live demo. I can edit the video. So if the video gets a little bit choppy, just imagine me crawling around on the floor picking up marbles. The 74HC595 shift register has 2 registers. It has a parallel register which we can depict with these 8 LEDs. But it also has an internal serial shift register that we can't see. So I'm going to depict that internal register with these marbles over here. You'll see I've got 8 clear marbles here, and that represents the internal shift register with 8 zeros in it. The idea is that when we send a pulse to the clock, it will read the data pin and add 1 more bit to the circuit. So let's see if we can make this work. I'm going to add 1 more marble to the rack here. I hope you can see this is a black one. This is going to be a number 1. So the equivalent of that over here is I'll hold the data button down and I'm going to push the clock button. When I push the latch button, this LED comes on. What's happened internally is that we have pushed these digits over 1 notch. We still have 8 marbles, but the first one now is black. Now if I add another one, this time I'll leave it low. We push the clock button. We shove the internal register, stay put. We shove the internal register over 1 notch, and the latch displays our LED in the second position. The internal register has the black one in the second position. I'll push the clock again. That's the same as adding another 0 to the batch. Oh, come on. Get off of there. Yes. That's the same as adding another 0 to the batch. And so when we push the latch button, bingo, it drops there. So that's how this thing works. Every time we add another piece of data to this end of the internal register, it pushes the last one off the line. Right there, we latch it, we move over. Now just to prove my point, let's add a 1 to the circuit. That means this guy goes off, these move over. I will hold the data button down, push the clock, that's my 1, and when the latch is clicked, there it is right there. What could be simpler than that? In that last demo, you saw me push the latch button every time I pushed the clock button so that we could display what was happening down here. You don't have to latch it every time you clock it. You can send a series of bits into your register and wait until they're all there and then latch them and display the results. Before I demonstrate that, let's get rid of these LEDs that are already lit. You remember our clear line here, which we have held high? I'm going to move this over to the ground bus and push the latch. Watch what happens. They all go out. You can use that line to clear all of the bits in your registers in one simple move. We'll put it back to the high side where it belongs. Let's say we want to set up a register and then display it after they're all in. So let's say I want to bring in a 1 bit right here. We'll take 1 out. I'll do that by holding the data button down and pushing the clock. Now I want to put in a 0 bit and take 1 out. We'll do that by just pushing the clock. Now let's say that I want to put in 2 1 bits. In goes 1, out goes 1, in goes 1, out goes 1. We could do that by simply holding the data button down and pushing the clock twice. Once, twice. I'll put another 0 bit in right there. Take 1 off the line. All I have to do is clock it. Now finally, let's say I want to add 3 more 1s. Put 1 in there, take 1 off. Put 1 in there, take 1 off, put 1 in there, take 1 off. Then I'll enter those just as I did before. Hold the data button down, and we go 1, 2, 3. I still have 8 bits in my register. 1, 2, 3, 4, 5, 6, 7, 8. I have a 1, 0, 1, 1, 0, 1, 1, 1. Let's touch our latch and see if we light up the same. And there you have it. 1, 0, 1, 1, 0, 1, 1, 1. So we can send a whole stream of bits into our register and then latch it when we're ready. Okay, now it's time to talk about this extra LED that I put in down here. This red one. I want to connect it to this current limiting resistor and run it back here to pin 9 on our shift register. So I'll just move this guy over here. Now, as you recall, pin 9 on the shift register is the serial data out pin. This is the one we use when we want to hook up more than one shift register in a cascading line. For example, when we laid out our printed circuit board that we sent off to JLC PCB, we use 2 of these shift registers. This register right here handles all of the individual segments in each of our digits. The second shift register over here, which is exactly the same chip, handles the cathodes. This is the one that determines which digit on our display is actually going to light up. These chips are set up so that we can link them together. We can daisy chain the shift registers and let the bit stream cascade from one chip into the other. This means Pin 9 on the first register, which is the serial data output pin, is directly linked to pin 14 on the second register, which is the serial data input pin. Now let's look at it on our breadboard. Our red LED is now set up to show you what's actually going on with this serial data output pin. When it goes high, the red LED is going to come on. So I've got my internal register here displaying 1-1 kind of in the middle here. I'm going to set up the LEDs right here to match exactly what we have there. So I need 3 zeros, 2, 3, 1, 1, and 4 zeros. 1, 2, 3, 4. We'll latch that. And so what we have here in LEDs matches what we have in our display with our marbles to represent the internal register. In particular, I want you to watch what happens to this red LED as our black marble makes its way down this path. So to start out with, I'm going to send another 0 into the mix. I'll push clock here. I will take another 0, another clear marble, and put it there. Knock that one off. And let's latch it and see the same thing here. I'll add another 0. Knock one off. Send it to the clock here and latch it here. Now, this is when things start to happen. We'll add one more 0. We'll knock that one off, which means when we clock it, this one over here is going to come into the last position. Watch. Our red LED has already come on. That means that pin 9 over here has gone high. We haven't latched this yet, but it's already going to the other register if we had one. Now, you saw me push the button. You have to understand, the red light did not come on until it had already done all of the shifting internally. It's now ready for the next move. So I will hit the latch button here. Our LED has moved over, so everything matches. Now, if I add one more 0 to the mix, we're going to have all zeros when we get done. I'll knock this one off. We represent that by clicking the clock. Watch the LEDs. It's gone back off again. And when we latch it, there are no LEDs. So you got to see how that serial data output pin works. As I said earlier, there are several really good videos here on YouTube done by other contributors that explain a lot of what's going on with the same IC that I'm talking about. And typically you'll see them cascade a couple of these. In fact, I could do that. I could take another chip here. This is identical to the one we're using there. I could plug this in here. We would take this pin 9 over here and bring it around and plug it into pin 14 in this position, and I would have to then also jump the clocks. They would be tied together. Everything over here would be connected to everything over here except for the data pin. And then I would have to run maybe 8 more LEDs on the board and set everything up like that. I'm not going to do that because you can go see it, but I want to show you something that you probably won't see on others. Now, I don't know how practical this is, but I do know it's pretty interesting. We can take, for example, a jumper here, and we will take our this pin 9 here. It's coming over here to this resistor. We could take that and plug it in here. What I'm doing is I'm taking the data output pin and tying it back in to the data input pin. Watch what I do here. So let's say we want to add a 1 to our circuit, and we'll take the 0 off the other end as we've been doing I think it took off one too many, right? 1, 2, 3, 4, 5, 6, 7, 8. We're good. My eyes turned away there for a minute. Okay, I want to add a 1 so the data button goes down. Notice that the LED is coming on. That's because we're backfeeding all the way through here. So this is what, I mean, it's too bad I didn't have an LED on that button all along. So clearly our data pin is high right now. I will clock it, just like that, and we'll latch it. And you'll see it's in the first position. Now, let me just move it over about five steps with zeros. Okay. 1, 2, 3, 4, 5. We'll latch it. And then I'm going to make my marbles match what we have there. Got to cheat and fudge, but you've seen all how this goes. All right, so this is where it's going to get fun. We're going to add another 0. Basically, all I'm going to do is key the clock. Then knock that guy off. We'll latch it. Remember, this is the time when I make the next move, the red LED is going to come on. So we'll add a 0 here, knock off that 0 there, which happens when we clock this. Bingo, that LED has come on. And I'll latch it. So now we're in the right position. But notice now, I'm not pressing this button here. Instead, our pin 9 is going to backfeed the high to our data input. So, can you see what's going to happen? If I add a 0 right here, and I knock this guy off, okay, I will clock it. Our pin has gone out, and now I'm going to latch it, and look, this guy came back on again. So I didn't really add a 0. It wasn't a 0 that I put in. It was a 1. It was a 1 that was being backfed from our data input. So just for fun, forget the marbles for a minute. Get them out of the picture. Let me just walk this thing through. I'll go clock, latch, clock, latch, clock, latch, clock, latch, clock, latch, clock, latch. Our data pin is always low when I'm doing this until now. When I go clock, our data pin has just come high. I'll latch it. I'll go clock again. And when I latch it, it reappears over there. This represents what we would actually see if we had a second shift register and another set of LEDs. We could add another one to the mix and latch it. So now we have 2 of them. And now we'll just shove those over and back again. So you'll see the data output pin over here come high and low as we walk these things along. So what kind of projects can you build with these shift registers? Obviously you could do the 7-segment displays like we did in our series here, and you've probably seen these LED scrolling marquee signs. They come in real handy to build those. And what about these cubes with all the dancing LEDs? It's perfect use for a 74HC595 chip. I hope you've enjoyed this video. I certainly enjoyed putting it together for you, and I look forward to seeing you again soon. And hey, don't forget to subscribe, like, and share.